The simplest organic compounds are hydrocarbons, compounds containing only carbon and hydrogen.
Hydrocarbons are classified into two main types: aliphatic and aromatic. Aromatic hydrocarbons are hydrocarbons that contain benzene rings or certain other similar structures. Aliphatic hydrocarbons are those that do not contain benzene rings. We can also classify hydrocarbons into saturated and unsaturated types. Saturated hydrocarbons contain only single carbon-carbon bonds. Propane and cyclopentane are examples. Unsaturated hydrocarbons contain carbon-carbon double or triple bonds. The term unsaturated indicates that the hydrocarbon can accept a number of additional hydrogen atoms to become saturated. Butadiene and propyne are examples of unsaturated hydrocarbons.
Alkanes are aliphatic, or open-chain hydrocarbons, in which only single covalent bonds between carbon atoms are present. The general formula of alkanes is CnH2n+2.
The names and molecular and structural formulas for the first 10 alkanes with straight chains are shown in the table. Notice that these alkanes form a homologous series. The first 3 members of the alkane homologous series have no structural isomers, but starting with 4 carbon atoms, alkanes can form branch structures. For example, with 5 carbon atoms, 3 structures are possible: 1 with a straight chain and 2 with branch chains. As we learned before, these are structural isomers. If we compare the density and boiling points of the isomers, we can see that branched chain isomers have lower densities and boiling points. Branching prevents close contact of neighboring molecules, so that the strength of the intermolecular van der Waals forces is reduced.
To name an alkane, we follow a set of rules according to the International Union of Pure and Applied Chemistry nomenclature.
First rule: identify and name the longest straight chain. The name consists of 2 parts. The first part of the name indicates the number of carbon atoms in the chain. The ending tells us that the molecule is an alkane. The name hexane means an alkane with 6 carbon atoms. Straight-chain alkanes are known as the normal or N-alkanes, for example, N-hexane. Second rule: for branched-chain alkanes, name each branch, which is called a substituent. The substituent group formed when a hydrogen atom is removed from an alkane is called an alkyl group. Note that alkyl groups are named by dropping the ending -ane from the name of the parent alkane and replacing it with the suffix -yl. Knowing the names of the alkyl groups, state the name of the alkane that indicates the longest straight chain of carbons. Number the carbons in that longest straight chain, and if 2 numbers could describe the point of attachment, choose the smaller. In our example, numbering from the left-hand side gives the name 4-methylpentane, but numbering from the right-hand side gives 2-methylpentane. The correct IUPAC name, therefore, is 2-methylpentane. Third rule: if the same substituent appears more than once, we must prefix the alkyl group name and give the positions of each alkyl group on the longest straight chain, keeping the numbers as small as possible. Consider the example of an isomer of nonane. There are 3 methyl substituents in the molecule. Numbering the longest chain from the right-hand side gives the substituents the numbers 2, 4, and 5. But numbering the carbons from the left-hand side gives the numbers 2, 3, and 5. By choosing the smaller numbers, we get the correct name of 2,3,5-trimethylhexane and not 2,4,5-trimethylhexane. Fourth rule. If a branched chain alkane contains more than one type of alkyl group, we place them in alphabetical order. Consider the example of an isomer of nonane. The methyl group is attached to carbon 2 and the ethyl group to carbon 3. The name of this isomer of nonane is, in alphabetical order, 3-ethyl-2-methylhexane.
Hydrocarbons that contain carbon atoms joined to form a ring are called cyclic hydrocarbons. When all carbon atoms of the ring are saturated, the hydrocarbons are called cycloalkanes. The general formula of cycloalkanes is CnH2n.
Let us look at the structure of cyclobutane. The abbreviated structural formula is called line angle drawing. Each line represents a carbon-carbon single bond, and each angle represents a carbon atom. Hydrogen atoms do not appear in the formula. Some other examples of cycloalkanes will appear on the screen. These are cyclopentane, cyclohexane, and ethyl cyclohexane. Perhaps you remember that the presence of two substituents in a molecule of cycloalkane allows the possibility of cis-trans isomerism. For example, 1,2-dimethyl-cyclopentane can exist as cis and trans isomers. When naming cycloalkanes, we use the prefix cyclo, and the same rules as before. Let us name the cycloalkane shown on the screen. Because there is only one methyl group on the ring, there is no need to number the atoms of the ring. The name is methyl cyclohexane. Number the atoms of the cyclopentane ring, and name the substituents in alphabetical order. The name is 1-ethyl-2-methyl cyclopentane.